Right, so in section 3.4, we're going to solve logarithmic and exponential equations. And what you're going to try and do is you're going to try and condense the problem so that you have one logarithm or one exponential function in the problem if you can. So these are a couple of strategies that you can use to go through and solve them. So the first one is if the equation is in logarithmic form, rewrite it in exponential form. So that's our first strategy. Second one is if it's in log form, try to write it in exponential form. So just write it in the opposite form that you see it in. And then finally, the third one is try to use your properties of logs to condense it down into a single logarithm. And then you can go back to the first step there, you write it in exponential form. So let's see what this is going to look like. So these are the examples in the notes. I mix them up a little bit because they sometimes make more sense this way. So for this first one here, if I can write these exponentials with the same base, I'm going to do that because if the bases are the same, the exponents have to be equal. So 16 I'm going to rewrite as 2 to the 4th, and since both of these have a base of 2, then the exponents have to be equal. So 3x equals 4, so x is 4/3. Now come back to number 2. If you look at number 3, it's similar to this one. So I want to write it as this 2 to the x by itself. So I need to divide both sides by 3 to start. So I'll have 2 to the x equals 14. And now, unlike this previous one here, I can't write 14 as 2 to an exponent. So for this one, I'm going to have to rewrite this in log form. So I'm going to rewrite this as log, the base is 2 of 14, and remember logarithms equal exponents, and my exponent is x. So if I leave it like this is the exact value, log base 2 of 14. And that's fine. This is better than writing it as a decimal estimate. So I'm going to leave it like that. If you go back to the second example, now we'll go back to base of e. I can't write e and 72 with the same base, so I'm going to have to write this in log form. So for this one, then I would have log, the base is e of 72 equals the exponent, and the exponent is the x. And then remember, you can rewrite log base e as natural log of 72. And leave it as natural log 72 because that's the exact value. Let's see. Number 4, I'm going to try to get it to look like number 2 by getting the e to the exponent by itself. So if I add 3 to both sides to start, I'll have 4e to the 2x equals 5. And then I can divide both sides by 4. So e to the 2x equals 5/4. And now I'm back to this point like I was in this previous problem. I can't write both of these with the same base, so I'm going to rewrite it in log form. So my log is log base e of 5/4, and logarithms equal exponents. My exponent is 2x. Log base e I can write as natural log, and equals 2x, and then I can divide both sides by 2. So I have x equals, I'm going to write this as 1/2 natural log of 5/4. So this answer is good. Other ways that you can write this answer that are equivalent, you could make it natural log of 5/4 to the 1/2 power. You could rewrite that, you could make it the square root of the top, which is root 5, and square root of 4, which is 2, for the bottom. That's also equivalent. So any of those answers are fine. They're all exact values then. For number 5, this one's a little bit different. This one you have just a single log on the left and a single log on the right, and they both have the same base. Since they both have the same base, since the bases are the same, the things that you're taking the logs of are equal to each other. So 5x minus 1 equals the x plus 7. And then you're going to solve for x. If I subtract x from both sides, I'll get 4x. If I add 1 to both sides, I'll get 8. So x is 2. As you do these problems too, you want to check to make sure that when you solve for x, and if I put this back in here, I'm going to get a positive value. So if I plug in 2, I'll have 2 and 7, which is 9, is a positive value. If I plug in 2 on this side, I'm going to have 10 minus 1, which is 9. So this is fine. If I end up with something like log of, like say -1, this is no good. You can't take the log of a negative value or of 0. Right, and then example 6, almost the same as one of those previous ones that had a base of e in exponential form. We'll subtract 5 from both sides, so 2 ln x equals negative, 4 minus 5 would give me -1, and then divide both sides by 2. So you get natural log of x is -1/2, and now this is in logarithmic form. We want to solve for x, so we got to get rid of the log, so we're going to write it in exponential form. So natural log is log base e. So my base is e. Logarithms equal exponents, so my exponent is -1/2 equals x. You can leave it like that. Other way you could write your answer if you want to make this a positive exponent, you can. Typically the book will leave e to a negative exponent if it ends up having a negative exponent. And number 7 is almost the same problem, but now it's log base 5 instead of natural log, so divide both sides by 2 to start. And then rewrite this in exponential form just like we did at this point here. So my base is 5, exponent is 2, equals 3x. 5 squared is 25. And then I could divide both sides by 3, so 25/3 is my x. And I didn't do it for this last one, but if you plug in 25/3 up here, you're taking the log of a positive value, so it's fine, that value checks. Alright, number 8. I have more than one log in the problem, so I'm going to condense this first. That was the third strategy that we could do. So if I combine this left side together, this addition is going to condense into multiplication. And while I'm at it, I'm going to put this 2 up here as an exponent. You've got to get rid of the coefficients as well. So now on both sides, this is log base e, natural log. Since the bases are the same, the things that I'm taking the logs of are equal. So x minus 2 times 2x minus 3 equals x squared. If I FOIL the left side here, I'll have 2x squared minus 3x minus 4x would be minus 7x plus 6 equals x squared. And then set this equal to 0. And then we can solve. We get x minus 1, x minus 6. So x is 1 or x is 6. And the last step is we've got to check and make sure that these values are not going to give us logs of negatives. So back up in this original here, if I plug in 1, I'm going to have natural log of 1 minus 2, which is -1. This is no good. It's an extraneous solution. And then 6 is okay in the first one, the second it's okay in all of them. So x equals 6 is my only solution there. All right, now this example isn't in your notes. This is like a bonus. So you're lucky that you get this one. So let's condense this left side. This is subtraction now, so we'll make this division. So x plus 1 over x minus 1 equals natural log of 2. Again, since both sides have a base of e, natural log, I can eliminate the logs in the problem. So the things I'm taking the logs of are equal. Actually, no, I don't need these parentheses here. Let me just get rid of that. So x plus 1 over x minus 1 equals 2. And then maybe we'll make that 2 over 1. So I can cross multiply. I'll have x plus 1 equals 2 times that quantity x minus 1. And distribute that 2. And then combine like terms. If I subtract x from both sides and add that negative 2 to both sides, I'll get x is 3. If I check up here, in this original here, if I plug in 3, it's going to be okay on the first one. If I plug in 3, 3 minus 2, 1 is 2. So my 3 checks in both pieces there. So I'm good.